Welcome. Today we are looking at functional groups, focusing on alcohols, aldehydes, ketones, and carboxylic acids. This is a key topic in your chemistry exams for SS2. Pay close attention. Let us begin. First, let me explain what functional groups are. A functional group is a specific atom or group of atoms within a molecule that determines its chemical properties. The functional group is the reactive part of the molecule. It gives the compound its characteristic reactions. Different functional groups have different properties. They react in different ways. The functional group determines the class of the compound. For example, alcohols contain the hydroxyl group. Aldehydes contain the carbonyl group at the end of the carbon chain. Ketones contain the carbonyl group in the middle of the carbon chain. Carboxylic acids contain the carboxyl group. Understanding functional groups is essential for organic chemistry. It allows you to predict the reactions of compounds. It allows you to name compounds correctly. Now let me explain alcohols. Alcohols are organic compounds that contain one or more hydroxyl groups. The hydroxyl group is OH. The general formula for alcohols is ROH. R is an alkyl group. The simplest alcohol is methanol, CH3OH. Methanol is also called wood alcohol. The second alcohol is ethanol, C2H5OH. Ethanol is the alcohol in alcoholic drinks. The third alcohol is propanol, C3H7OH. Propanol has two isomers, propan, 1. Ol has the hydroxyl group on the first carbon. Propan, 2. Ol has the hydroxyl group on the second carbon. Alcohols are classified as primary, secondary, or tertiary. A primary alcohol has the hydroxyl group on a carbon attached to one other carbon. A secondary alcohol has the hydroxyl group on a carbon attached to two other carbons. A tertiary alcohol has the hydroxyl group on a carbon attached to three other carbons. The classification affects the reactions of the alcohol. Now let me explain the nomenclature of alcohols. The IUPAC system is used to name alcohols. The name has three parts. The root indicates the number of carbon atoms in the longest chain containing the hydroxyl group. The suffix indicates the type of compound. For alcohols, the suffix is -ol. The prefix indicates the position of the hydroxyl group. The hydroxyl group is given the lowest possible number. For example, methanol has one carbon atom. Ethanol has two carbon atoms. Propan, 1. Ol has three carbon atoms with the hydroxyl group on carbon 1. Propan 2-ol has three carbon atoms with the hydroxyl group on carbon 2. The name also includes the position of substituents. For example, 2-methylpropan, 1-ol has a propanol chain with a methyl group on carbon 2 and the hydroxyl group on carbon 1. The rules for naming alcohols are similar to alkanes. The main difference is the suffix and the position of the hydroxyl group. Now let me explain the physical properties of alcohols. Alcohols have higher boiling points than alkanes of similar size. This is because of hydrogen bonding. The hydroxyl group can form hydrogen bonds. The hydrogen bonds hold the molecules together. This requires more energy to break. Alcohols are soluble in water. Small alcohols are miscible with water. Larger alcohols are less soluble. This is because the nonpolar hydrocarbon part becomes larger. Alcohols are less dense than water. They are colorless liquids at room temperature. Methanol, ethanol, and propanol are liquids. The physical properties of alcohols are determined by the hydroxyl group. Now, let me explain the chemical properties of alcohols. Alcohols undergo several important reactions. The first reaction is combustion. Alcohols burn in oxygen to produce carbon dioxide and water. The reaction is exothermic. For example, ethanol burns according to the equation C2H5OH plus 3O2 equals 2CO2 plus 3H2O. Alcohols are used as fuels. The second reaction is oxidation. Primary alcohols are oxidized to aldehydes and then to carboxylic acids. Secondary alcohols are oxidized to ketones. Tertiary alcohols are not easily oxidized. For example, ethanol is oxidized to ethanol and then to ethanoic acid. The oxidation of alcohols is an important reaction in organic chemistry. The third reaction is esterification. Alcohols react with carboxylic acids to form esters. The reaction is catalyzed by acid. For example, ethanol reacts with ethanoic acid to form ethyl ethanoate and water. Esters have pleasant smells. They are used in perfumes and flavorings. The fourth reaction is dehydration. Alcohols are dehydrated to alkenes. The reaction is catalyzed by acid and heat. For example, ethanol is dehydrated to ethene. The reaction is C2H5OH equals C2H4 plus H2O. Dehydration is used to produce alkenes. Now let me explain aldehydes. Aldehydes are organic compounds that contain the carbonyl group at the end of the carbon chain. The carbonyl group is C equals O. The general formula for aldehydes is RCHO. The simplest aldehyde is methanol, HCHO. Methanol is also called formaldehyde. The second aldehyde is ethanol, CH3CHO. Ethanol is also called acetaldehyde. The third aldehyde is propanol, C2H5CHO. Aldehydes are named by replacing the E of the alkane with al. For example, methane becomes methanol, ethane becomes ethanol, propane becomes propanol. Aldehydes are reactive compounds. They undergo addition reactions and oxidation reactions. Now, let me explain the physical properties of aldehydes. Aldehydes have higher boiling points than alkanes, but lower than alcohols. They do not have hydrogen bonding. They have dipole-dipole forces. The boiling points increase with molecular size. Aldehydes are soluble in water. Small aldehydes are soluble. Larger aldehydes are less soluble. They have pungent odors. Methanol is a gas. Ethanol is a liquid. The physical properties of aldehydes are determined by the carbonyl group. Now, let me explain the chemical properties of aldehydes. Aldehydes undergo several important reactions. The first reaction is oxidation. Aldehydes are easily oxidized to carboxylic acids. For example, ethanol is oxidized to ethanoic acid. The reaction is CH3CHO plus O equals CH3COOH. The oxidation of aldehydes is used in the laboratory to distinguish them from ketones. The second reaction is reduction. Aldehydes are reduced to primary alcohols. For example, ethanol is reduced to ethanol. The reaction is CH3CHO plus H2 equals CH3CH2OH. The third reaction is addition. Aldehydes undergo nucleophilic addition reactions. They react with hydrogen cyanide to form cyanohydrins. They react with ammonia derivatives to form imines. The reactions of aldehydes are important in organic synthesis. Now, let me explain ketones. Ketones are organic compounds that contain the carbonyl group in the middle of the carbon chain. The general formula for ketones is RCORS. The simplest ketone is propanone, CH3COCH3. Propanone is also called acetone. The second ketone is butanone, chatre, coq, du chatwe. Ketones are named by replacing the E of the alkane with -1. For example, propane becomes propanone. Butane becomes butanone. The position of the carbonyl group is indicated by a number. For example, butan 2,1 has the carbonyl group on carbon 2. Ketones are less reactive than aldehydes. They do not undergo oxidation easily. They undergo reduction and addition reactions. Now, let me explain the physical properties of ketones. Ketones have higher boiling points than alkanes, but lower than alcohols. They do not have hydrogen bonding. They have dipole-dipole forces. The boiling points increase with molecular size. Ketones are soluble in water. Small ketones are soluble. Larger ketones are less soluble. They have pleasant odors. Propanone is a liquid. The physical properties of ketones are similar to aldehydes. The main difference is the position of the carbonyl group. Now let me explain the chemical properties of ketones. Ketones undergo several important reactions. The first reaction is reduction. Ketones are reduced to secondary alcohols. For example, propanone is reduced to propan-2-ol. The reaction is CH3COCH3 plus H2 equals CH3CHOHCH3. The second reaction is addition. Ketones undergo nucleophilic addition reactions. They react with hydrogen cyanide to form cyanohydrins. They react with ammonia derivatives to form iminase. The third reaction is halogenation. Ketones undergo halogenation in the presence of acid or base. The reactions of ketones are important in organic synthesis. Now, let me explain carboxylic acids. Carboxylic acids are organic compounds that contain the carboxyl group. The carboxyl group is COOH. The general formula for carboxylic acids is RCOOH. The simplest carboxylic acid is methanoic acid, HCOOH. Methanoic acid is also called formic acid. The second carboxylic acid is ethanoic acid, CH3COOH. Ethanoic acid is also called acetic acid. The third carboxylic acid is propanoic acid, C2H5COOH. Carboxylic acids are named by replacing the E of the alkane with oic acid. For example, methane becomes methanoic acid, ethane becomes ethanoic acid, propane becomes propanoic acid. Carboxylic acids are weak acids. They dissociate partially in water. They react with bases to form salts. Now let me explain the physical properties of carboxylic acids. Carboxylic acids have higher boiling points than alcohols. This is because of hydrogen bonding. They form dimers. Two molecules are held together by two hydrogen bonds. Carboxylic acids are soluble in water. Small carboxylic acids are soluble. Larger carboxylic acids are less soluble. They have sharp, unpleasant odors. Ethanoic acid is a liquid. The physical properties of carboxylic acids are determined by the carboxyl group. Now, let me explain the chemical properties of carboxylic acids. Carboxylic acids undergo several important reactions. The first reaction is neutralization. Carboxylic acids react with bases to form salts and water. For example, ethanoic acid reacts with sodium hydroxide to form sodium ethanoate and water. The reaction is CH3COOH plus NaOH equals CH3COONA plus H2O. The second reaction is esterification. Carboxylic acids react with alcohols to form esters. The reaction is catalyzed by acid. For example, ethanoic acid reacts with ethanol to form ethyl ethanoate and water. Esters are used in perfumes and flavorings. The third reaction is reduction. Carboxylic acids are reduced to primary alcohols. For example, ethanoic acid is reduced to ethanol. The fourth reaction is decarboxylation. Carboxylic acids lose carbon dioxide when heated with soda lime. For example, ethanoic acid is decarboxylated to methane. The reaction is CH3COOH equals CH4 plus CO2. A common exam question asks you to distinguish between primary, secondary, and tertiary alcohols. Here is a sample answer. A primary alcohol has the hydroxyl group on a carbon attached to one other carbon. A secondary alcohol has the hydroxyl group on a carbon attached to two other carbons. A tertiary alcohol has the hydroxyl group on a carbon attached to three other carbons. The classification affects the oxidation products. Primary alcohols form aldehydes and carboxylic acids. Secondary alcohols form ketones. Tertiary alcohols are not easily oxidized. Another exam question asks you to distinguish between aldehydes and ketones. Here is your answer. Aldehydes have the carbonyl group at the end of the carbon chain. Ketones have the carbonyl group in the middle. Aldehydes are easily oxidized to carboxylic acids. Ketones are not easily oxidized. Aldehydes can be distinguished by Tollens reagent. Aldehydes give a silver mirror. Ketones do not. Aldehydes can also be distinguished by Fehling's solution. Aldehydes give a red precipitate. Ketones do not. Another exam question asks you to describe esterification. Here is your answer. Esterification is the reaction of a carboxylic acid with an alcohol. It produces an ester and water. The reaction is catalyzed by acid. For example, ethanoic acid reacts with ethanol to form ethyl ethanoate and water. Esters have pleasant smells. They are used in perfumes and flavorings. The reaction is reversible. The ester can be hydrolyzed back to the acid and alcohol. Let me give you a quick summary. Functional groups determine the properties of organic compounds. Alcohols contain the hydroxyl group. They are classified as primary, secondary, or tertiary. Aldehydes contain the carbonyl group at the end of the chain. Ketones contain the carbonyl group in the middle. Carboxylic acids contain the carboxyl group. Each functional group has characteristic reactions. Alcohols undergo combustion, oxidation, esterification, and dehydration. Aldehydes undergo oxidation, reduction, and addition. Ketones undergo reduction and addition. Carboxylic acids undergo neutralization, esterification, reduction, and decarboxylation. Practice these concepts. When you have them down, move to Topic 10.